My name is Gil Moore. This is my 63rd year in the space business. I started out working on flying experiments aboard captured German V-2 rockets at White Sands Proving Ground in New Mexico in 1947. I'm here tomorrow to go to Morehead State University to work with them on a new project that we call POPACS, for Polar Orbiting Passive Atmospheric Calibration Satellites. This is a program that is intended to measure the way in which the density of the Earth's upper atmosphere varies in response to explosions on the sun, or what are called coronal mass ejections. When the sun burps, it creates clouds of energetic particles that stream into the Earth's magnetic field and then cascade down into the upper atmosphere near the poles and cause the atmosphere to swell up by 2 or 3 orders of magnitude. We're going to put those into polar orbits over the north and south poles at an altitude varying from 200 kilometers to about 1,500 kilometers in eccentric orbits, and then track those with Air Force Space Command radars and students around the world tracking those same satellites, the solar reflections off of those satellites, with optical telescopes. And their data, coupled with the Air Force Space Command radar data, will be used to measure the orbits of the satellites and the changes in those orbits that are caused by drag in the Earth's upper atmosphere. And as the solar eruptions take place, the atmospheric density changes, and that causes the orbits of the satellites to change. And the whole objective of the program is to increase the accuracy of predictions of the future orbits of the satellites in response to those changes in the atmospheric density. So that way we can more precisely avoid collisions between debris, both man-made and natural, in the atmosphere, and the assets that we have up here, the space station and the space shuttle and vehicles like that. Morehead State is going to have the opportunity to use its big 21-meter dish to track the satellite and send commands. And then they will continue tracking the basic satellite, the 2U CubeSat, to measure the characteristics of the energetic particle flux that's flowing down into the polar regions to increase the density of the atmosphere in response to the coronal mass ejections.